Hello children, how are you all? Hope you are preparing well for your second terminal examination. We have already completed our chemistry portions for second terminal exam, but still I think we did not discuss our exercise questions. Okay, so today we are going to discuss the exercise questions of the chapter Atoms, Molecules and Radicals. Okay, so let us begin. You can all take page number 58. Page number 58. In page number 58, the first question is, define the following terms. The first term given here is atoms. The definition of atoms is already given there in page number 48. You might have seen a blue box in page number 48. Just under that, you can see a few sentences given in italics. That paragraph should be written as a definition for atoms. Okay, so definition of atom, and all these definitions are to be written in your notebook. Okay, children. Moving on to the next one, molecules. Definition of molecules is again given there in page number 49. You might have seen a small heading, a molecule. Under that, you can see a few sentences given in italics, and that is the definition of molecules. Moving on to the third one, radicals. What do you understand by the term radicals? The answer for that question is given there in page number 51. Okay, page number 51. Definition of radicals is given there. And again, you also can see two different types of radicals. All these are very important, but here the definition of radical is only asked. So you can write that particular paragraph given in inverted comma as the answer. Now, moving on to the next one, valency. Definition of valency given in your textbook is just the combining capacity. The term combining capacity is only given in your textbook as the answer, but I want you to write the answer of valency as the one which I have given you in your note. Okay, it is the number of electrons donated or accepted or shared by an atom during a chemical reaction so as to attain chemical stability. And that would be the definition of valency. And for the exam, you are expected to write this definition. Okay, children. Now, moving on to the third question and the fourth question we have seen. Now, the fifth one. Okay, what is periodic table? The definition of periodic table is asked here, and it is given there in page number 53. Okay, in page number 53, you might have seen the definition of periodic table given. Now, moving on to the second question. Write the names of the elements present in the following compounds. The first one is common salt. Common salt, the formula is NaCN. NaCl. So, which are the elements present here? Sodium and chlorine. The second one is ammonia. Ammonia. Write the names of the elements present in the following compounds is the question. So, name of the compound is sodium chloride. The elements present are sodium and chlorine here. Now, the second question, the question is ammonia. So, whenever you get these type of questions, children, always go for writing the formula of the compound first. So, that will be easy for you to identify the elements present in it. Okay, ammonia is NH3. Write the formula first, and then you can mention the names of the elements present in it, nitrogen and hydrogen. Okay, moving on to the next one. It's sulfuric acid. So write the formula of sulfuric acid. It's H2SO4. It consists of hydrogen, sulfur and oxygen. Now the next element, the next compound given here is glucose. Formula C6H12O6. This is glucose. Okay, so it consists of carbon, hydrogen and oxygen. Moving on to the next one, sodium hydroxide. The formula of sodium hydroxide is NaOH. So which are the elements present here? Sodium, oxygen and hydrogen. Now the next element is, the next compound asked here is acetic acid. Acetic acid. Formula of acetic acid is CH3COOH. CH3COOH is the formula of acetic acid. So this acetic acid consists of which all elements in it? Carbon, hydrogen and oxygen. Carbon, hydrogen and oxygen. How many atoms of carbon are present in this compound, children? There are 2 carbon atoms. Okay, how many hydrogen atoms are present? 3 plus 1, 4 hydrogen atoms and 2 oxygen atoms are present in a molecule of acetic acid. Moving on to the third question. What does each of the following represent? What does each of the following represent? The first one is 2CO2. 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 2CO2 can be read as 2 molecules of carbon dioxide. 2 molecules of carbon dioxide consisting of 2 atoms of carbon and 4 atoms of oxygen. Don't forget to write the second part of the answer. Moving on to the next question. 2H2S. So first, how will you start reading this compound, children? You have to identify what is given here. Need not bother about the number which is represented on the left hand side. First think or identify which is the compound. Name the compound first. The compound is hydrogen sulfide. How many molecules of hydrogen sulfide? 2 molecules of hydrogen sulfide consisting of 4 atoms of hydrogen and 2 atoms of sulfur. Okay, moving on to the next one. 5H2SO4. 5H2SO4. So what is H2SO4? It is sulfuric acid. So if it is 5H2SO4, it is read as 5 molecules of sulfuric acid consisting of 5 into 2, 10 atoms of hydrogen, 5 into 1, 5 atoms of sulfur and 5 into 4, 20 atoms of oxygen. Hope you are getting me. Okay, so this is the way that you have to answer the questions. Okay, so there are 2 parts for this particular answer. That is, first you have to explain it in terms of number of molecules, and then in the second part of the answer you have to explain it in terms of number of atoms of each element. Now the next question is 6NaNO3. 6NaNO3. What is NaNO3? It is sodium nitrate. By now, I hope you are able to read the formula of compounds when given. Okay, so how can you read the formula of a compound, children? First, see the front part, I mean the first part of this compound. This is sodium, isn't it? And this is called the basic radical. That means the positive part of this particular compound, the basic radical. And what is this one? NO3 minus. Hope you remember, isn't it? NO3 minus represents nitrate. If NO3 radical is present, it is denoting which particular radical is NO3 minus. How can you name it? It is nitrate radical. Okay, so sodium and nitrate. So how do you name this compound? It's named as sodium nitrate. Sodium nitrate. And you might have learned that sodium holds a positive charge and nitrate radical is represented like this. Okay, and on exchange of the valencies of these two, we know that Na holds 1 positive charge, NO3 holds 1 negative charge. So as the numbers, as the valencies are the same, it gets cancelled. You need not write these numbers at the bottom of their symbols. That is how you are writing the formula as NaNO3. So NaNO3 is sodium nitrate, and there are 6 molecules of sodium nitrate consisting of how many atoms of each element? 6 into 1 for sodium. So 6 atoms of sodium, 6 into 1 again for nitrogen, 6 atoms of nitrogen, and 6 into 3, 18 atoms of oxygen. That's how you answer this question. Okay, I hope this part is also clear. And question number 1, already I have told you to write the answers of those questions in your notebook. And question number 2, again, you have to write it in your notebook, children. And question number 3, again, the next one that you have to write in your notebook. Moving on to the 4th question. Write the symbols and valencies of the following radicals. This question you can mark in your textbook itself, there is no problem. But it should be written in your answer. The answer should be written in your textbook properly, neatly. Okay, near to those questions. No, need not mark the answers here and there. Just write the correct answers near to those questions. Okay, so question number 4, write the symbols. So the first one is magnesium ion. Magnesium ion. See, if simply symbol of magnesium is asked, you will be representing it as Mg. If it is magnesium ion, you have to represent it in the form of an ion itself, Mg2 plus. Have you followed? This is how you will write the answer, and no other answers are there for this particular question. Moving on to the next one, ammonium. Ammonium ion is asked. Ammonium. Children, NH3 is ammonia. Have you followed? This is ammonia, and this is a compound. Ammonia is a compound. It is not a radical. Ammonia is NH3 and is not a radical, while NH4 plus, this is a radical. This is a radical holding one positive charge, and this is named as ammonium. Did you understand? This is actually a part of a compound. This is actually a part of a compound. Have you followed? There is something, the negative part of this particular radical is still waiting to combine with this positive part. So, only then it makes a compound. So, it's actually a part of a compound. Okay, so never get confused between ammonia, which is a compound, and ammonium ion, which is a radical, positively charged radical. Okay, so this is the answer for the question asked here. Okay, now moving on to the next one, carbonate. Carbonate. How to represent carbonate radical? Carbonate. Children, you have to be thorough with all these radicals and their representations, and only then you will be able to answer the questions for this terminal exam. Okay, carbonate is represented as CO3 2 minus, carbonate. Next one is nitrate. How to represent nitrate? NO3 minus. NO3 minus. This is nitrate radical. Now moving on to the next one, oxide. Oxide. Oxide is represented as O2 minus. Okay. The next one is bisulfate. Okay. We already know how to represent sulfate radical. If there is a term called bi in front of sulfate radical, what will be present there in the symbols? What will be present? Hydrogen will be present, isn't it? So it is represented as HSO4 minus. HSO4 minus, that is bisulfate. Now the next question is aluminium ion. Aluminium ion is represented as Al3 plus. Aluminium ion. Okay. Now moving on to the fifth question. Name the following radicals. This question's answers can also be written near to the questions in your textbook. Okay, there is no problem. So you can write the answers in the textbook, but it should be written neatly. Okay, so the first one shown here is SO4 minus. SO4 minus. How to name this radical, children? This is sulfate. Sulfate radical. Now the next one is HCO3 minus. HCO3 minus. If it is CO3, it's actually a part of carbonate radical, isn't it? So there is H present. So it is bicarbonate. Bicarbonate. Now moving on to the next one, it's OH minus, hydroxide. The answer is hydroxide. The next one is Cr2O7 2 minus. This is dichromate radical. Which is this radical, children? Dichromate radical. So hope you got the answers for all these questions. Now moving on to question number 6. Name one ion for each of the valencies +1, +2 and +3. Okay, so which are the different elements which show the following valencies? +1 valency is shown by which all elements? +1 valency is shown by which all elements? See children, potassium, sodium, lithium, all these shows +1 valency. They are monovalent positive ions. Now, so only one is asked, you can write just one. Moving on to the next one is with +2 valency. +2, magnesium, Mg2 plus, Ca2 plus. Isn't it? Only one question is, one answer. One ion is to be written here, but I'm just writing more so that if asked, you will be able to write. Now, +3, aluminium shows +3 valency. At the same time, ferric, Fe3 plus, ferric ion. It is holding a valency of 3 plus. You have learned that iron shows variable valency. Copper also shows variable valency. That means it can exhibit more than one valency. Iron can exist in two different valencies, plus 2 and plus 3. Copper can exist in two different valencies, plus 1 and plus 2. Okay, so learn all those things very well. Moving on to question number 6b. Name one ion for each of the following valencies. The first one, minus 1. Minus 1 valency. See children, fluoride, chloride, bromide. All these are with minus 1 valency. Okay, now moving on to the next one, minus 2 valency. Oxide, sulfide, these are the elements with minus 2 valency. Now minus 3, which are the ones with minus 3? Nitride, phosphide, all these are with minus 3 valency. Okay, so please do understand all these and learn the box thoroughly. Okay, I think I have given you 2 or 3 boxes to learn where radicals and metallic, non-metallic ion representations, all these are very, very important. Moving on to question number 7. So question number 6 and its answer should be there in your notebook. Okay, moving on to question number 7. The valency of calcium is 2. Write the valencies of the other radicals in the following compounds. Valency of calcium is given to you and you have to identify the valency of the neighboring substance, neighboring part. You have to identify its valency. So the first one is CaO. So what is said? What is the clue given here? Calcium with valency 2. Valency of calcium is 2. Okay, so what will be the valency of oxygen in this compound? That is a question. See children, we have already learned that we write the formula of a compound by the exchange of the valencies of the two radicals, isn't it? And we have seen that if the two combining parts, that means the basic radical and the acid radical, holds the same valency, no number will be written as subscripts. Okay, so here we don't find any number as subscripts, which means that valency of calcium, they have already said that valency of calcium is 2. So what will be the valency of the neighboring one? That will be also 2, because we don't find any numbers written at the bottom. Have you followed? So valency of calcium is 2 and that of oxygen is also 2. We know that oxygen shows minus 2 valency and here calcium shows plus 2 valency. After exchange, you will write the formula of compound as CaO. Okay, so what is the valency of the neighboring element here? It is 2. I hope you are getting me. Now, the next one, CaOH twice. So, again, here you have to find the valency of the neighboring radical. Valency of calcium is already mentioned. Valency of calcium is 2. So, what is the valency of the neighboring radical? How can you identify, children? See, valency of calcium is the number given to the neighboring radical as its subscript, isn't it? So, calcium will be given the valency of the neighboring radical. Calcium will be getting the valency of the neighboring radical. Do you find any number written at the bottom of the element calcium? Do you find any number here? There is no number written, which means it's simply 1. If there is nothing written, it represents that the valency is 1. Have you followed? So we have seen that calcium has valency 2 plus. Hydroxide ion shows valency minus 1. So after the exchange of the valencies of these radicals, we get the formula as Ca. 1 is given for calcium and OH should be placed together in a bracket. OH should be placed together in a bracket. Why? Because we are going to give a particular number. That means valency of calcium is to be given for this group OH. So O and H together should be given this number 2. So that is why the bracket is used. If the bracket is not used, it is represented as CaOH2, and this is wrong. Have you followed, children? So that is why we are representing it as CaOH twice. So from that, what is clear? OH radical shows a valency of 1. Now moving on to the next question. It is calcium carbonate given here, CaCO3, calcium carbonate. In calcium carbonate, it's already said that calcium shows a valency of 2. And what about carbonate? What about carbonate? Carbonate radical. We should know how to represent a carbonate radical. We know that it is CO3 2 minus. And this 3 is actually a part of the radical. Don't think that this 3 is something that is obtained after exchange. No, it's actually a part of this radical's CO3. Did you understand? And see the valency of that radical CO3? It is 2 minus. Have you followed? And do you find any number written as subscript for calcium? No number is written, which means it's already said that calcium shows valency 2, and the valency of the neighboring radical should be written here under calcium. You don't find any number under calcium, so which means that CO3 shows a valency of 2. Yes, it shows a valency 2. That means calcium as well as CO3 holds the same valency, that is 2. Moving on to the next one, CaCl2. CaCl2. Have you followed, children? So, from this what is clear? It's already said that calcium has valency 2. Okay, so valency of the neighboring radical will be represented here under calcium, and no number is seen here under calcium, which means that there is a number 1. Okay, so what is the valency of chlorine? Valency of chlorine is 1. Okay, we know that it is represented as Ca2 plus and Cl minus 1. Okay, we'll exchange the valency, and after the exchange, we get the formula like this. So if you want to identify the valency of the neighboring radical, and if the valency of the first element is given to you, what is the only thing that you have to check? What is written as the subscript in the formula under that particular element, that number. Have you followed, children? That is what you have to check. Have you followed? And here in all these questions, you can see calcium. It's already said that calcium holds valency 2. Okay, so if the neighboring element also has the same valency, that is 2, no number will be written under calcium. Did you understand? If the neighboring element shows a particular valency and which is not 2, you will be able to see some number written under calcium. Did you understand? But here in this case, CaCl2, you can understand that calcium's valency is given to chlorine, and that is 2, and chlorine just shows valency 1, and that is why here under calcium, though it is not written as 1, it is understood that the number is 1. Have you followed? I hope this part is also clear to everyone. So, please do write the answers of this question also in your notebook using the method which I have used here. Okay, so that will be more easy for you to understand while you learn. Now moving on to question number 8. Name the following compounds. Name the following compounds. So I shall write the names of the compounds. See, already the formula is given here. So I think I don't have to write it. I'll just tell you. First, let's copy down the formula of the compound. NH4 twice SO4. NH4 twice SO4. So from this, what do you understand? From this, what do you understand regarding the valency, children? What do you understand? This is ammonium ion, NH4, isn't it? And this is sulfate radical, isn't it? Sulfate radical. Okay, and sulfate radical shows a valency 2, and that is given for ammonium ion as a whole, and that is why the bracket is used. Okay, and number 2 is represented outside the bracket, and ammonium ion holds a valency 1, and that is what SO4 group gets. So as it is 1, it need not be mentioned. Okay, now how to name this compound? This is ammonium, this is sulfate, so it's ammonium sulfate. That's how you read this compound. The next one is CaNO3 twice. CaNO3 twice. This 2 is a valency of calcium, and NO3 group has valency 1, and that is what calcium gets. No number is written here, which means it is 1. So this is nitrate radical, this is calcium. So how do you read this? It's calcium nitrate. Always the positive ion will be represented first. Have you followed? And the negative ion will be represented the next. Okay. So this is calcium nitrate. The next compound is FeS. FeS. How to read this compound? FeS. See children, we have already learned that iron shows 2 different valencies, that is +2 and +3, isn't it? So if it is +2, okay, if it is +2, you call it as ferrous, isn't it? Ferrous. Okay, but we are not sure whether it is ferrous or ferric. If it is Fe3+, it is ferric. So we are not sure whether it is ferrous or ferric. So how can you identify whether it is ferrous or ferric? We'll go for writing the valency of this one. Here, in this particular question, all these are not required, but still, to name this compound perfectly. Otherwise, you have to write it as iron sulfide. But as iron shows variable valency, it is more important to mention it as ferrous or ferric. So, I am giving you a simple tip to identify whether iron shows a valency of +2 or +3 in this compound. Okay, so we know the valency of sulfur is -2, isn't it? It is -2, and this 2 will be given for iron after the exchange of radicals. After the exchange of valencies, isn't it? After exchanging the valency, definitely this 2 will be given for iron and will be written at the bottom. And do you find any number written at the bottom of iron? No number is written. And under sulfur also, no particular number is written. So what does it mean? Both the radicals, that is iron and sulfur, both shows the same valency. As we know, the valency of sulfur is 2, the valency of iron will also be 2, and that is why no number is written at the bottom. If the valency of iron is 2, how do you name this compound? It is ferrous sulfide. It is ferrous sulfide. It's named as ferrous sulfide. Okay. Now moving on to the next one, Na3PO4. Na3PO4. If it is Na3PO4, how do you name this compound? Na3PO4. Have you followed, children? So how do you name this compound? This is sodium and this is phosphate radical, isn't it? PO4, 3 minus, and that 3 is what sodium gets. Okay, Na3. Okay, and sodium shows a valency of +1, and that is why no number is given particularly for PO4 group. Okay, PO4 group is a single group, it's a single unit, and no number is given in common for PO4. This 4 is meant only for this oxygen. Okay, don't get confused. So how do you read this compound? This is sodium and this is phosphate, sodium phosphate. You read it as sodium phosphate. The next one is NH4OH. NH4OH. How do you name this compound? This is ammonium, this is hydroxide. Ammonium hydroxide. The next one is CuCO3. CuCO3. Okay, so how do you name this compound, children? How can you name this compound? We know that either you can call it as copper carbonate. It's copper carbonate. CO3 is carbonate. Here also, I can tell you one thing. Copper shows 2 different valencies, Cu2 plus and Cu plus 1. Isn't it? That means valency 2 and valency 1. That means 2 different valencies are shown by copper. So how can you identify the valency of copper in this compound? We know carbonate is holding a valency CO3, 2 minus, isn't it? 2 minus, and that 2 minus should be seen here under copper. But do you find any number here under copper? No, no number is written. From that, what can you understand? The valency of carbonate radical is same as that of copper. Okay, both shows the same valency, and that is how you write the formula as CuCO3. So valency of copper, if it is 2 or if it is 2 plus, how do you name this compound? Cupric, isn't it? If it is Cu plus, you call it as cuprous, isn't it? If it is Cu2 plus, you call it as cupric. So how do you name this compound? It's cupric carbonate, or simply you can call it as copper carbonate. Okay, now the next one is HgO. HgO. This is mercury and this is oxygen. Okay, so how do you name this compound, children? Mercuric oxide. Mercuric oxide. We followed. It is mercuric oxide. Now, the next one, ZnCl2. How do you name this compound? Zinc chloride. Zinc chloride. Don't simply write as zinc chlorine. That is not a compound. You have to name the ion. Okay, Cl is actually existing in the form of an ion in this compound. So it is named as zinc chloride. Zinc chloride, because you know that it is a combination of Zn2 plus and Cl minus. Valencies of these two are exchanged. Okay, I'll just write at the top Zn2 plus and Cl minus. So valencies are actually exchanged. That's how we get the formula as ZnCl2. Okay, so there are two different radicals in this compound, zinc and chloride. So the name of the compound is zinc chloride. The next one is ZnS. ZnS. How do you name that? ZnS. This is sulfide ion and this is zinc ion. So how do you name this? Zinc sulfide. So you have to always start reading from this end to this end. Alright, you call it as zinc sulfide. Now moving on to the next one, H2S. You know this compound. This is hydrogen sulfide. You name it as hydrogen sulfide. Okay, so I hope you understood how to name all these compounds. It's very important. You should know how to name the compounds given. Okay, now moving on to question number 9. So question number 8 should be written in your notebook. The question as well as the answer should be written in your notebook. Okay, moving on to question number 9. Write the molecular formula. How do you write the molecular formula of a given compound? Okay, so let us see that. To write the molecular formula of a compound, let us see the first one, sodium sulfide. Sodium sulfide. If you are given such a question, sodium sulfide, how do you write the formula, children? Sodium sulfide is very simple, right? Na plus, sodium ion. Sulfide ion is S2 minus. Exchange the valency. So sodium gets 2 and sulfur will be given 1, number 1. So the formula is Na2S. So while you write the formula of compounds, if their names are given, this step is compulsory. Don't simply write the formula of the compound alone. You have to write the radicals separately, show the exchange of valencies, and then you have to write the formula. Okay, this method is also called crisscross method. How do you call, children? Write the formula of a compound by crisscross method. Okay, write the formula of the compound by crisscross method. In crisscross method means just exchange of valency. That's what they mean. Okay, moving on to the next one, magnesium oxide. The next compound is magnesium oxide. Magnesium oxide. How do you write the formula of this compound by crisscross method? Mg2 plus is magnesium ion, oxide is O2 minus. After the exchange of valency as the numbers are the same, you need not write any number at the bottom of their symbols. So the formula of the compound is MgO. While you write the formula of a compound, there won't be any number written at the top of their symbols. Be very careful. Okay, after the exchange of valency, you won't find any number written at the top of their symbols. Numbers will be seen only as subscripts at the bottom. Okay, now moving on to the next one, calcium hydroxide. Calcium hydroxide. How to write the formula of calcium hydroxide? How can you represent the formula of calcium hydroxide? First, Ca2 plus. Hydroxide is OH minus. So, after the exchange of valency, you get the formula as Ca, OH group as a whole should be given this number 2. Isn't it? And after the exchange of valency, my dear children, you don't have to use the symbols. Only the numbers are exchanged. Okay, you are not asked to just represent the symbols after the exchange. Okay, we'll exchange only the numbers. CaOH twice. Okay, now moving on to the next one. It's hydrogen chloride. Hydrogen chloride. Hydrogen chloride. So while you write the formula, first write the name. Okay, hydrogen chloride. As you write the formula of hydrogen chloride, first hydrogen ion, chloride ion. So both shows valency 1. So no number is to be represented. You can write the formula as HCl. The next one is sulfuric acid. Sulfuric acid. So in the case of sulfuric acid, actually the formula is only asked. So you can write it as H2SO4. Okay, and there are certain other names given for sulfuric acid, dihydrogen sulfate and all will be said. So in that case, you can use the radicals and their valencies can be exchanged and shown. So here, sulfuric acid is simply asked. To write the formula is only asked in the question. So you can write it as H2SO4, sulfuric acid. You need not go for exchange of any valency. Okay, you can write the formula of sulfuric acid by exchange of valency. That is H plus and SO4 2 minus. Okay children, so 2 will be given for hydrogen, number 1 will be given for SO4 group, so it becomes H2SO4. Okay, so this is also possible. Moving on to the next one, iron 2 sulfide. What is given in the question? Iron 2 sulfide. Iron 2 sulfide. This is 2 given in bracket. So what is this Roman numeral 2? It actually represents the valency of iron in this compound. Valency of iron in this compound is represented using this particular notation. Okay, so it is Fe. You can identify that the valency is 2 plus. For those elements which shows variable valency, they may represent the name like this. So from this name, you can easily understand what is the valency of that particular element in this compound. So it is Fe2 plus and sulfide is S2 minus. After the exchange, the numbers are the same. So you can write the formula as FeS. The next compound is Fe. It's given as iron 3 sulfate. What's given? Iron 3 sulfate. Iron 3 sulfate. So what do you understand here children? This 3 represents the valency of iron in this compound. So how do you write? Fe3 plus. Okay, sulfate is represented as SO4 2 minus. Exchange the valency. After exchanging, number 2 will be given for Fe. So it is written as Fe2. Number 3 is given for SO4 group. SO4 group. This 2 is already given for iron, so you need not bother about that 2 anymore. So SO4 group as a whole gets a number that is 3. Okay, I hope you understood the method of writing the formula. The formula is Fe2 SO4 thrice. Okay. Now the next one is nitric acid. You know the formula of nitric acid. It's HNO3. You know the formula. You can simply write it as HNO3. Okay. Calcium phosphate is the next compound. Calcium phosphate. Calcium phosphate. So how do you write it, children? First write Ca2 plus. Phosphate is PO4 3 minus. Exchange the valency. After exchange of valency of these two radicals, you will be getting it as Ca3. This 3 will be given for calcium, 2 will be given for PO4 group as a whole. So you have to use a bracket. PO4 twice. Calcium phosphate. The next one is aluminium sulfate. Aluminium sulfate. Aluminium sulfate. So how do you represent? Aluminium is Al3 plus. Sulfate is SO4 2 minus. So 2 will be given for aluminium, 3 will be given for SO4 group. Okay, so how do you write the formula after the exchange of valency? How do you write the formula, children? Al2 SO4 as a whole will be getting the number 3. So you have to use a bracket. Al2 SO4 thrice. Al2 SO4 thrice is aluminium sulfate. Now the last one in that group is magnesium nitride. Magnesium nitride. Magnesium nitride. How do you write the formula? Magnesium nitride. This magnesium nitride, magnesium ion should be represented first. Nitride is N3 minus. Exchange the valency. So 3 will be given for magnesium. So it is Mg3. Number 2 will be given for nitrogen. So it is N2. The formula is Mg3N2. So this is how we write the formula of compounds by crisscross method. So all these questions are their answers, and all these steps which I've used should be written in your notebook. Okay, children? So don't forget, you have to do it perfectly. Okay? Now we are moving on to the next question. The valency of sodium is 1. Write the molecular formula of the following compounds of sodium. That is what is asked in the question. So already they have said that valency of sodium is 1. So you have to write the molecular formula of certain compounds of sodium. So what can we do, children? First, I have written the formula of the compound that they have given us. It's sodium oxide. If it is sodium oxide, and they have already said that the valency of sodium is 1, so you can write it as Na plus 1. Okay, we know that it is a metallic atom, so it will hold a positive valency. And what about oxide? Oxide is O2 minus. This is something that you should know. Okay, now after the exchange of valency, the formula of the compound will be Na2O. Na2O. This is the formula of sodium oxide. Moving on to the next compound, sodium sulfate. How to write? We know that the valency of sodium is plus 1. Sulfate is SO4 2 minus. Now we are going to exchange the valency of the two radicals. You will get the formula as Na2SO4. Okay, moving on to the next one, sodium carbonate. Valency of sodium is Na plus 1. Valency of sodium is plus 1. Carbonate is CO3 2 minus. Okay, so after exchange of valencies, we get the formula as Na2CO3. This is how we get the formula of sodium carbonate. The next compound is sodium hydroxide. Sodium hydroxide. So how do we write the formula of sodium hydroxide? We know that the valency of sodium is plus 1. So we write that first, Na plus 1. Hydroxide is OH minus. Now on exchanging the valency, we get the formula as NaOH. Why do we get it as NaOH? Because both the radicals show the same valency, NaOH. Now the next compound is sodium nitrate. Sodium nitrate. How to write the formula of sodium nitrate? Let us see that. Sodium nitrate. So first we have to write the valency of sodium. We know that it is Na plus 1. Nitrate is represented as NO3 minus. So now what is the next step? Just exchange the valency. So you get the formula as NaNO3 because nitrate also shows valency 1 and sodium shows valency 1. So both after exchange you will get the formula as NaNO3. Okay, so 10th question is also completed. This also you have to write in your notebook. Now moving on to question number 11. What is variable valency? Certain elements show more than one valency. That is what you call as variable valency. Give 2 examples of elements showing variable valency. We have already learned they are iron and copper. Okay, moving on to question number 12. Give the group number of the following elements present in the periodic table. Group number of the following elements present in the periodic table. So children, we have already seen that in your textbook you have a part of the periodic table given, and I have given you certain relations. Like I have told you, group number of a particular element is equal to the number of valence electrons. The number of valence electrons. Isn't it? I have told you that if you want to identify the group to which a particular element belongs, it will be equal to its number of valence electrons. Okay, how many electrons are present in the outermost shell? If it is 1, the group number to which that element belongs is 1. Okay, now if an element has 6 electrons in the outermost shell, it belongs to group number 6. Okay, that means you have to use the Roman numerals. If it is 1, 1A. If it is 6, 6A. In such a way you have to represent the group numbers. Okay, because in a periodic table we do have elements of group A as well as B. Okay, B group elements are not mentioned in your textbook, so you'll be learning about B group elements later. So we have to concentrate only on A group elements. So because of that, these letters, I mean A, should be mentioned along with the group number. Okay children, now what is the next relation? Group number will be equal to the number of valence electrons, and period number. Period number, I told you in a periodic table we do have vertical columns called groups and horizontal rows called periods. Okay, so to which period does the particular element belong? That will be equal to the number of shells. Period number will be equal to the number of shells. Have you followed? If an element uses 3 shells to fill its electrons, so it belongs to period number 3. Did you understand? If it uses 5 shells to fill its electrons, it will be a member of period number 5. Okay, if it uses only 2 shells to fill up the electrons, so it will be a member of period number 2. Okay, so period number will be equal to the number of shells used by that particular atom to fill its electrons. Did you understand? So what is the first step that you have to do if you are asked to identify the position of an element in the periodic table? Position of an element means you have to mention the group number as well as the period number to which the element belongs. So what is the only thing that you have to do? To write the electronic configuration of that particular element. Okay, here you are asked to write the group number only they have asked. So we'll write both. Write the group number of the element magnesium. Okay, so if you are given such a question, what will you do? You have to write the atomic number of magnesium, and that is 12. Write its electronic configuration. Its electronic configuration is 282. How many electrons are there in the valence shell? 2. So magnesium belongs to which group? It belongs to group number 2A. It belongs to group number 2A. Okay, now how many shells are used by magnesium to fill its electrons? 3 shells are used, and it is a member of period 3. Did you understand? It is a member of period 3. When you represent group, you have to use these Roman numerals along with A. Okay, so if it is period number, you can use a normal numbers. Have you followed? Now, what about the next element? So it belongs to group number 2A and period number 3. Now, what about the next element? It is carbon. Carbon, atomic number of carbon is 6. So the next step is to write electronic configuration 2, 4. So it is a member of which group? Belongs to group number 4A. Okay, and it uses how many shells to fill its electrons? 2 shells. So it's a member of period number 2. Okay, now moving on to the next one, sulfur. Sulfur, its atomic number is 16, electronic configuration is 286. So 6 electrons are there in the valence shell. So it belongs to group number 6A. And it's a member of period. How many shells are used, children? 3 shells are used. Isn't it? K, L, M. 3 shells are used. So it belongs to period number 3. Okay, so this is the way you can identify the position of any element in the periodic table if you know its atomic number. Okay, now the next one is neon. Neon. What is the atomic number of neon? Neon has atomic number 10. Electronic configuration is 2, 8. Have you followed, children? So here, see, we haven't learned a group 8A. Instead of that, we have a group that is after 7A, we have seen which group, children? 0 group. 0 group. 0 group means the valency of those elements present in 0 group will be 0, which means it will not be going for any transfer of electrons like donating or accepting or sharing. It will have complete configuration, a stable configuration, octet configuration or doublet configuration will be there for those elements. See, there are 8 electrons in the outermost shell of neon, which means it belongs to group number 0. It belongs to 0 group. Okay, belongs to 0 group, or simply you can write it as group 0. Belongs to group number 0. Have you followed? Including B group elements. Actually, we have, if you are using the normal numbering method, actually there are 18 groups. Have you followed? Including A group and B group. If you use normal numbering method, there are actually 18 groups. Okay, so these type of elements with stable configuration will belong to group number 18. As we are using Roman numerals here, let us use group 0. Did you understand? In your textbook also, it is the same given. So we will use group number 0. Now, the next thing is the period. The period to which it belongs. Period to which it belongs. 2 shells are used. So it belongs to period number 2. Have you followed, children? So this is the way that we try to identify the position of an element in the periodic table. Okay, so this also you have to write in your notebook. Moving on to question number 13. An element belongs to group 5A. An element belongs to group 5A. Listen very carefully. Element belongs to group number 5A. From this, what all information do you get, children? If it is a member of group 5A, there will be 5 electrons in its valence shell. Okay, 5 valence electrons. 5 electrons will be present in its outermost shell. Now, what would be its valency? Name 2 such elements. Okay, you are asked to write 2 elements with this type of valence electrons. I mean 5 valence electrons. The first question is to write its valency. What will be the valency of this particular element which is a member of group number 5A? There will be 5 valence electrons. To attain stable configuration, it has to accept 3 more electrons. As it accepts 3 more electrons, what will happen? It will be getting a stable electronic configuration. So, the valency of the element belonging to group number 5A will be 3. Valency will be 3. Valency will be 3. And what is the next part of the question? Two such elements which shows negative 3 valency. Which are those two elements? We have already seen phosphide and nitride radical. Don't you remember? Only the name of the elements are asked. So you can write it as phosphorus and nitrogen. Phosphorus with atomic number 15 and nitrogen with atomic number 7. Okay, see the electronic configuration of phosphorus is 285 and that of nitrogen is 25. Have you followed? I hope it is clear to all of you. Okay, now moving on to the last question. An element belongs to group number 2. So, okay, what does it mean? If it belongs to group number 2, it is a member of group number 2A with 2 valence electrons, isn't it? What would be its valency? If 2 valence electrons are there, it will be a metal and it will donate its electrons, isn't it? So, valency will be 2 plus 2, isn't it? Plus 2. Write the formula of molecules of compounds it will form with elements in 5A, 6A and 7A groups. Okay, they are asking you to write the formula of the compounds if this particular element. So, I am going to give a name for this element. Let this element belonging to group number 2A, let it be X. And its valency is plus 2. And the next element is a member of group number 5A. So, I am going to name that element as Y. And what will be the valency of that particular element with valency? If it is a member of group number 5A, its valency will be minus 3. Isn't it? Just now we have seen minus 3. So, now after exchange of valency, we will get the formula as X3, Y2. Okay, this is a member of group number 2. This is a member of group number 5. Okay, now if X is forming a compound with an element belonging to group number 6A. So what shall we do, children? Here X is the same member with valency 2 plus, and I am going to take Y is taken, so let it be Z. This is a member of group number 2A. This is a member of group number 6A. So what will be the valency of Z? What will be the valency of Z, children? 6A, isn't it? So it will be gaining 2 electrons. Valency will be 2 minus. Okay. So after exchange of valencies, you will be getting the formula of the compound as XZ. Have you followed? Now moving on to the last one. If X is the element with group 2A belonging to group number 2A, its valency is 2 plus, and let A be the element which belongs to group number 7A. Okay, so A is a member of group number 7A. Have you followed? Now let us see if it is a member of group number 7A, what will be its valency? There will be 7 electrons in its outermost shell. It will be accepting 1 electron to attain the stable configuration. If it accepts 1 electron, its valency will be minus 1. Isn't it? Now the valencies are ready. So how do we write the formula of the compound? After exchange of valency, we get the formula as XA2. XA2. Have you followed, children? So this is how we write the formula of compounds of different elements. Where different elements combine to form a compound, we have to consider, or we have to check to which group does it belong. Then you can identify what will be its valency. Once when you calculate its valency, it's easy to write the molecular formula. I hope the things are clear to you. So thank you, children. Thank you very much. Have a great day.